Alright, so what does converse mean? When we have a theorem, we have the converse, so it's backwards. So if B, then A. We're going to do if A, then B. So our converse of the Pythagorean theorem says that if a triangle is formed by 3 segments, but if there's the bridge that the 2 smaller sides aren't larger than the bigger side, then your car is going to be in water. Okay? So not every 3 sets can form a triangle. Like this one, 4 plus 4 is 8, which is bigger than the biggest side, so it's going to be a triangle. 3 plus 3 is 6, which is smaller than the biggest side, so it's going to fall in the water. So when you're testing them, you want to set up these inequalities. So, like with this example, you have 7 plus 10 needs to be greater than 19. 10 plus 19 needs to be greater than 7. And 19 plus 7 needs to be greater than 9. So when you check these, are they going to work? So you have 17 greater than 19. Whoop. That's our first one. So that one automatically says that no, this can't be a triangle. Okay? You don't need to necessarily write out every single of these inequalities to see. If you test one and it's not greater than, then you can just stop right there. Okay? Yeah. So we have 2 sides that are concrete. There's 4 and there's 9. What's the range? Word that you probably haven't heard in a little bit. What's the range that side can be? So what's that asking? With range? Cameron.
It's going to be less than 9.
Okay.
But not more than 4.
So you can look at it, got this cool little thing. So 9 and 4 are concrete. They're not going to change size. But we can move this around. So all of these things are triangles, right? But watch what happens as we get closer and closer and closer. We're at 13. That's kind of like when your 2 sides of the bridge make exactly that side, the third side. It's like level with the water, so that bridge isn't going to work. Okay? So what would that be? That inequality be? X is greater than 13.
Equal to, greater than, equal to.
Not quite, not quite.
Equal to, greater than, less than. I said them all.
You said it while you're just guessing. Okay, it has to be less than 13. Because look, 12.6, 12, 11, all of these work. So, but when it hits 13, that's when it makes a line. So x has to be less than 13. But when we make it smaller, x can be little, but then what happens when it turns to 5?
Minus 4.
So it has to be greater than 5, but less than 13. So we said that x has to be greater than, what does it have to be bigger than?
The
5. And x has to be less than 13. But instead of writing 2 inequalities, can we mash them into 1?
Yes.
How can we mash them into 1?
5 is less than x, then less than 13.
Very good. Okay, so instead of having 5 or x on this side, we can flip it and say 5 is less than x. And then you're just putting them in a line. How could we mathematically find 13 and 5 from these side lengths that we were given?
9 plus 4 is
13.
9 plus 4
And you said, okay, but instead of doing it like this, I'm going to show you with the inequalities that we did. So we had 9 plus 4 has to be greater than x. 4 plus x has to be greater than 9, and 9 plus x has to be greater than 4.
Okay. And it's like,
So this one gives us our 13 that we were looking for. Has to be smaller than 13. How can we solve this middle inequality? Subtract 4. That's just like if this was an equal sign in the middle instead of a greater than. So x is greater than 5. So those ones make sense, right? That's what we've been looking at. What about this middle one? How we would subtract 9, our subtraction code, and x is greater than, but kind of like Cameron just asked, can we have a negative one? Can't have a negative side leg. So you're always going to have one inequality that just is like an outlier. It doesn't matter. So we know the Pythagorean theorem is a squared. Hopefully you still remember this. A squared plus equals c squared. But we're actually going to take the converse of it, so we're going to switch it. What's that property called? When I put c squared equal to a squared plus b squared.
symmetric.
Symmetric. It's our butterfly one. Okay, we just switch it. Okay? So we can use the Pythagorean theorem if we don't quite know. We know it's a triangle, but we don't know if it's a right triangle. So instead of putting the equal sign there, I'm going to leave a box. Okay? So if our c squared is bigger than our a squared plus b squared, then it's going to be an obtuse. So think it's your c squared is getting big, so it's stretching out that triangle. Okay? But if our c squared is smaller than our a squared plus b squared, Nathan, put up your phone, then it's going to make our triangle a lot smaller. So it's going to be an acute triangle. Remember, what makes an obtuse triangle? Greater than 90. What makes an acute triangle?
Shorter than
Less than 90. What makes a right triangle?
90.
Okay? So if you plug in your side lengths to our Pythagorean theorem converse, and c squared is equal to a squared plus b squared, what does that tell you about the triangle?
It's 90. Right.
It is a right triangle. What if c squared is bigger than a squared plus b squared?
obtuse.
Obtuse. And the last one, if it's smaller. Can this be a right triangle? 5, 7, and 10. Why do you think it can't be?
Two of them don't add up to.
We don't want it to be equal, remember? That means our bridge is in the water. So if we have a river that's 10, and one side of the bridge is 7, and one's 5, are they going to meet above the water?
Yeah.
And you can show that, you can say 5 plus 7 is greater than 10. So yes, it's a triangle. Okay, next we need to use the Pythagorean theorem converse to see if it's obtuse, acute, or right. So we can write our c squared. For c squared, we don't know if it's a hypotenuse, but we're just going to use the biggest side. So c squared, leave a box, 5 squared plus 7 squared. Those are our a and b sides. So 10 squared is, leave that box there because we're not sure what it's going to be. 5 squared is 25 and 49. So what's 25 plus 49? 74. Is c squared bigger or smaller than 74? So what type of triangle is this?
Obtuse.
It's an obtuse triangle. So before you get into doing your c squared is greater or less than a squared plus b squared, you need to check if it can even be a triangle. So is 11 plus 18 bigger or smaller than 34?
Smaller.
Smaller. So that means your bridge doesn't meet and your car is in the water. Okay. So if it's not a triangle, can it be acute or obtuse or right? No. Nope. So you can just stop right there. You can say, no, it's not a triangle, and call it good.